Morning, folks. This is tutorial 11 in the playlist that's devoted on meshing in the 3D Experiences FEA solver, which happens to be incidentally Abacus. I'm going to be discussing the something that is not uh, closely looked at by users, and that is or at least novice user, and that is what are the positive and negative sides of a shell element, or top and the bottom surface of a shell element. Very frequently, when you use shell elements, you go ahead and just uh, march your way through the calculation, putting the pressure on the side that you want, and it doesn't look like it. You kind of turn it into a negative side or a negative number, etc. And it's going to work. It's about time that at least we know in 3D experience how this is looked at. Now, when a surface is given, and surfaces are places where shell elements end up. So when a surface is given, there is no positive or negative side to it. There is no preferential side. There is no positive or negative. There is no top and bottom. And this is why a surface by itself does not have any uh, preferential side. However, as soon as you take that surface and you measure it, such as in this case, I've meshed it into 3 4 noded elements, linear elements. As soon as you do that, you are defining a direction. You are defining a side. And because you have a right-hand rule. And what do I mean by that? When you create an element, you tell the software what are the nodes of that element. For example, if you look at element number 1, you can say the nodes are 6354 or 4635, 5463, etc. As soon as you do that, this is called the connectivity of the element or connectivity table. You have defined a right-hand rule. Okay? You have defined a direction of the normal that you can specify or at least visualize by curling your thumbs, curling your fingers, uh, chasing that connectivity sequence of numbers, and your thumb points in the direction of the positive side of that shell element. So here is a typical, the same problem. I've done the connectivity for the entire 3 elements. This is called connectivity table. And these are done internally. You don't deal with it directly unless you write, for example, an IMP file, and there you see that these are all listed. I remember 40 years ago, 40, I don't know, 40 years ago, I had to go ahead and using punch cards put input all of these numbers into uh, the model that I had. For example, for each element, I need a punch card, which, for example, element 1 on it, it was punch 7368. Card number 2, element number 2, it was type 2, element 2, nodes 2541, etc. But these days, you don't see that because it's done internally. However, that is exactly what defines a direction of the normal. For example, if you look at element number 1 and you follow the sequence 7368, you get a normal direction. Or if you look at element number 2, you follow element number 3, you follow 4635, you get a normal direction. But if you look at element number 2, which is the middle one in the table, if you follow 2541, that'll give you an opposite direction, and therefore the normal, positive normal to that element is actually, or normal to that element is in the downward direction. So in general, if element is E and the node numbering follows this pattern, this sequence, 1, 2, 3, 4, then we have defined the normal. Okay, so this direction of the arrow defines a top side or the positive side of the shell element, and the other direction, basically opposite to this normal, is the bottom side or the negative side of the uh, shell element. Now, in 3D experience, the positive side of a shell element is colored. If you ask for the display of the color to be is colored in magenta, and the bottom side or the negative side is colored in blue. Ordinarily, these colors are not specified unless you ask for it. You might say, okay, so first of all, let me quickly go through what is the process. I'll do an example for you. I'll put this slide on the screen for you, but let me go ahead. So if you have a surface like that, and I'm going to do this example for you, it can be asked to be colored. And notice that this top view shows, this view shows that the top is right there, and that is the negative side of the shell element. Whatever you're looking at is the negative side of the shell element or the bottom side of the shell element. And uh, if I can turn this thing, change this thing, if I wanted to, through the following sequence that I'm going to show you later on. But how do you get actually this thing to show up, this coloring to show up? So you go when you're in the mesher, and you have to mesh it. Obviously, positive and negative sides of a shell element means that you have a shell element. You have to have meshed it first. So first you mesh it, then while you're in the mesher, you click on the display tab, and over here, mesh visualization, you have four options. This top one doesn't show you any colors, and the one that shows you some kind of a normals there, you can see that. This is where the colors are displayed. Now, you might say that, can I see the normal, positive normal? Uh, you can, but not in 3D experience immediately, okay? I'll talk about that thing later on. So anyway, so to be able to see the positive and negative sides in the display tab, use the mesh visualization orientation. Okay, good, which is this. Now, how do you change that? While you're in the mesher, while in the mesher, if you find this icon which says meshing editor, and if you can't see it, just scroll this action bar at the bottom of the screen to the right. Eventually, you come across the meshing editor, and you click on it. You click on that, and this menu shows up. Notice that as soon as you clicked on it, this thing shows up, and down here on the very right, it says flip elements. That means flip element directions. Okay. So what happens if when you click on this, it says what is the surface that you want to flip its elements, and it looks like you should be able to do that for each individual element if you want. For example, I should be able to flip the direction of this, but not that. And in some software, you can do that, such as Abacus, you can do that. But in 3D Experience, even if you try to select this element here, right there, it takes the whole surface that that element sits on. So to one quick way of doing this thing is just flip all. So you select the surface, flip all, and it turns it the other way around. Now you might say, well, who cares? I mean, magenta, blue, positive side, negative side, who cares about where it is? Well, let me give you an example. And I'll do this in the next video. I just want to show you what happens. Notice that when you apply pressure, there is a button there on a surface or a shell, on a shell surface, basically. There is an arrow like that, and there's a number that you put in. So if you do this for that problem, for example, it bends down. Now, if you turn this thing into negative, it goes up. On the other hand, if this arrow is already down and you put a 0.1, notice that these two, they kind of look the same as far as the number and as far as the direction of these arrows go, okay? But they may look different as far as how they behave. In other words, if you don't pay attention to this arrow, if you don't pay attention to the positive or negative side, on what side you're going to put your pressure on, you just put the number in. Notice that this will look different from that. The behavior is going to look different. So I will go through this thing later on. And incidentally, if the the thing that you were looking at was actually already negative side, okay, then the behavior is different. If you look at these, for example, these two, look at these two. They look exactly the same. Look at these two. They look exactly the same, but the behavior is different. The reason is that you put the pressure on a side which is different from that. You see, numbers are the same, arrow is the same, they look the same, icons look the same, but when you run it, one goes up, the other one goes down. So we'll talk about this thing later on in the next video. In some of the software, this direction that I was talking about, this magenta color thingy, is, or the positive normal direction to the shell can be displayed like that. And you can do that also, but after you make a run. In the post-processing stage, you can show that. You cannot, or at least I don't know how to display the triads for the element coordinate system in 3D experience. It can be done, but at the stage, measuring stage, I'm not sure how this thing goes. Okay, so let me go ahead and do this problem for you. Now that I walked you through the process of how to display, how to flip, etc. I'm not going to do this kind of an example. That comes in the next video, which I believe video 12, but we'll do an example right now. Okay, so on a convenient plane, on that vertical plane, I will sketch a line 40 millimeters long. These numbers don't matter. It's just that I want to illustrate for you, and this give it dimension, as I said, 40 millimeters. Okay, exit and extrude it as a surface by 120 millimeters. So here's extrude 120. So we get our surface. Good. Let's apply some material on it. I'm going to assume that it's made out of steel. It really doesn't matter. These surfaces I don't want, incidentally. I'm going to hide them. And the sketch also I don't want. Hide them. Okay, good. So let's go to the tools. Create a material. I'll call it January 6, 2024. Steel. Okay. It's a shell. It's going to be created. The shell is going to be created, and I apply it, and then I go and input my numbers. And right now, it's just a cover, basically, a template that's created. Okay, right here, January 6, 2024, steel, and then I'm going to say apply. I can close that, apply to this, green check mark, and now we can go and input our numbers. All we need is basically simple static analysis. So I need a static linear analysis. So I just want structural, abacus multiphysics, mechanical, elasticity, elastic, 200 GPa, which is 200,000 MPa, and 0.3 Poisson ratio. And that's pretty much it. Now that I have a surface and a material on it, I go to the different ways of doing it, but I go to the structural model creation. That's to mesh it. Empty FEA model. Okay. And here's a mesher tab, right? Meshing tab. And I need a simple surface quad mesh. Click on it. You select that surface. I put down 40 millimeters linear element and say mesh. And I get my three elements. Okay, now I can display the side, positive and negative side. I haven't even defined the thickness of this. That's okay, we'll do that. But as soon as you mesh, as soon as you have created the connectivity, you can display the direction. Here is what I was talking about. Under the display, there is this mesh visualization. And There's four options that you've got. So what am I talking about? You go back here, under the display, there's mesh visualization, and there's four options in it. So let's go back there. Right now, it's the standard. The positive and negative sides are not shown. If you change that thing to mesh visualization orientation, you can see that there are colors. Now, to see it better, let me hide the surface itself. There's the surface, see that? Let me hide this. There, the top here, the top is the negative, the top meaning whatever you're looking at is the negative side or the bottom side of the shell element. And if you rotate it, look at the other side, it's the top side. Okay, so let's put it back, meaning like this, no problem. And I'm going to show you how to flip this, okay? So we go to, right, I told you that while you're in the mesher, there is an icon. While you're in the mesher, don't worry about this display, not the display. I can actually, let me see now, get rid of that. While you're in the mesher, while you're in the mesh, there is the meshing editor. You click on it, okay? And it says, select the 2D mesh to edit. Well, you see, I can just select. You can do it from the tree, or you can do it from the screen. Either way. And as soon as that you do that, this secondary menu appears down here. And what I got here is now the secondary menu down there. You can see this. All right. So we go here. You click on the flip. Now, if I say flip all, it'll turn everything into upside down. Everything will be magenta here. Or even if you selected one of the elements, the whole thing is selected. See that? Cancel. Cancel. Let's try it again. Flip. Flip. And then flip all. It'll do it for you. Let me say okay. You want to change it back? No problem. Let's change it back. Okay, so let me actually keep it like this. It doesn't matter. And let's do a quick run. Let's do a quick run, and we because the next video I'll actually go through one by one and show you what happens when I try to do these things. As a matter of fact, I will save it for the next video. Okay, so we're not going to do anything else here. All right, folks, good luck. Uh, in many cases, people don't pay attention to the positive and negative side of the shell, but sometimes it comes and bite us. Good luck.